Hello children, in today's lecture we are going to discuss about the exercises that we learned in our lectures. Okay, in your exercise first question it is given as when an equation is given. If you observe, the equation is 2PbO, that is in solid form, combined with carbon in solid form, giving rise to 2PbS plus carbon dioxide, that is in gaseous form. This is the equation given, and they asked different statements are given. So the statements are: lead is getting reduced, carbon dioxide is getting reduced, carbon is getting oxidized, and lead oxide is getting reduced. So here you have to be very careful, very simple to understand. So here lead oxide is getting reduced to form lead, and similarly carbon is getting oxidized to form carbon dioxide. So these two statements are correct, and the remaining two statements are wrong here. So first statement they gave lead is getting reduced, that is a wrong statement. Here lead oxide is getting reduced, so option A is wrong, and option B carbon dioxide is getting reduced, oxidized, so that is also wrong. And coming to third statement, carbon is getting oxidized, that C statement is correct, and lead oxide is getting reduced, that is also correct. So now they asked us to mark which statements are wrong. So the first option is A and B statements are wrong. So our option 1 will be correct for that question. And coming to the second question, so here Fe2O3 plus 2Al gives rise to Al2O3 plus 2Fe. That is the reaction that is given. The above reaction is an example of, they are asking that. So if you observe Fe2O3, in this oxygen is getting displaced and it is getting combined with aluminium. So here, and Fe is getting replaced here. So here what is happening? This oxygen is getting replaced and it is getting reaction with aluminium. So it becomes a double displacement reaction. We are having a displacement both for iron as well as oxygen. So it is a double displacement reaction. So in this question they asked what happens when dilute hydrochloric acid is added to iron fillings. So here what happens, the reaction you can observe here, we are adding iron, right, that to dilute hydrochloric acid which is in the aqueous form, that is added with iron fillings, they are in the solid form. So when these two get reacted, you will observe ferric chloride FeCl2 that will be in the aqueous form, and hydrogen gas will be released over here. So here three different options are given to us. So the first option is hydrogen gas and iron chloride are produced, that is the correct answer. So in the second one, chlorine gas and iron hydroxide are produced, no reaction takes place, iron salt and water are produced, all these are wrong. So we will go for the first option, hydrogen gas and iron chloride are produced in this reaction. Here the question is, what is a balanced chemical equation? Why should chemical equation be balanced? That is our question. So what will be the answer? You already know. So what is a definition? A balanced chemical equation has equal number of atoms for each element on both sides of the reaction. If you write a chemical equation, both the sides, the number of atoms should match with each other. So why we need to balance a chemical reaction is, first the law of conservation of mass. So that states that the matter cannot be created nor destroyed. So to accurately represent the proportions of reactants and products in a reaction, we need to go to balancing of a chemical equation. Here in this question, translate the following into chemical equations and balance them. So first one, hydrogen gas combines with nitrogen to form ammonia, right? Hydrogen gas combines with nitrogen to form ammonia. So here nitrogen in the gaseous form, hydrogen gas in the gaseous form, N2 and H2 gaseous forms, and ammonia is NH3. Now balancing the equation, you already know. So in this side 2 nitrogen atoms are there, this side 2 hydrogen atoms are there, and in this the right hand side we are finding 3 hydrogen. So this left hand side 2 hydrogens and right hand side 3 hydrogens. So you have to multiply with. So the original equation we write it as N2 plus H2 gives rise to NH3. So if you observe 2 hydrogens on the left hand side and 3 hydrogens on the right hand side. So simply you have to make that 6. So you multiply this with 2. Then it becomes 6 hydrogens. So we multiply here 3. So it becomes 6 and 6 both are managed. Now if you observe nitrogens in this side 2 nitrogens and 2 nitrogens. So it is completely balanced chemical equation. Coming to the second one, hydrogen sulfide gas burns in air to give water and sulfur dioxide. So hydrogen sulfide is H2S, that is in the gaseous form, that is combined with oxygen which is in the gaseous form to form water and sulfur dioxide. So water is H2O and sulfur dioxide is SO2. Now we need to balance this chemical equation. How you will balance the chemical equation, that you have to observe. So hydrogen this side 2 and oxygens 1, 2. Total 3 oxygens this side, and this side only 2 oxygens. So whenever you get this situation, you make this also 6 better. So multiply with 3. So you are getting 6 oxygens. So on the right hand side again we multiply this with 2. So here 4 oxygens, and here again you multiply with 2. Here again 2 oxygens. So total 6 oxygens you are going to get. Now you verify the other atoms. So if you do this multiplication, we are finding 4 hydrogens this side. So I multiply 2 with this. So here also I am getting 4 hydrogens. Now if you observe 2 sulfurs are there, and right hand side also 2 sulfurs are there. So this is the completely balanced chemical equation, that is 2H2S plus 3O2 gives rise to 2H2O plus 2SO2. Like that you need to balance the chemical equation. Please mention these forms also, gaseous form, in the liquid form, H2O is in the liquid form and SO2 is in the gaseous form. And what third equation, barium chloride reacts with aluminium sulfate to give aluminium chloride and precipitate of barium sulfate. That is the chemical reaction that is given. So barium chloride BaCl2, that will be in aqueous form. Aluminium sulfate Al2SO4 taken thrice, because for aluminium it is 3 valency and SO4 sulfate 2 is the valency. So Al2SO4 taken thrice, which is in the aqueous form. That is giving aluminium chloride AlCl3, right? And precipitate of barium sulfate BaSO4. That is the chemical equation. We write the chemical equation as BaCl2 plus Al2SO4 taken thrice, that gives rise to AlCl3 plus BaSO4. Once you write this equation, then you observe which one you need to balance. First you will start with the highest number of atoms. So SO4 here you find 3, but on the right hand side only one SO4 is there. So simply you multiply with 3 here. So now barium became 3. So to balance barium, again I put 3 here. Now if you observe, chlorine is 6 here. So here Cl3 we find. So multiply with 2. So here chlorine is balanced and Al2 already, aluminium 2 here balanced. So this is the complete balanced chemical equation. So 3 BaCl2 in the aqueous form, Al2SO4 taken thrice in the aqueous form, and AlCl3 in the aqueous form, and barium sulfate in the solid form. That is the precipitate. Okay, and the last one, potassium metal reacts with water to give potassium hydroxide and hydrogen. So potassium metal is K, H2O, water, and potassium hydroxide KOH and hydrogen gas H2. So potassium metal is in the solid form, water is in the liquid form, KOH is the solution aqueous form, and hydrogen is in the gaseous form. So once we write K plus H2O gives rise to KOH plus H2. Now we need to balance this equation. Hydrogens 3 oxygen, in this side 1 oxygen, and here 1 hydrogen and 2 hydrogens are there. So we need to balance that one. So what I can do, if I multiply with the 2 plus 2 4 hydrogens. So here also I multiply with 2. Now it is 4 hydrogens matched, but here I got 2 potassium, so multiply with 2 here, so then it will be balanced. Potassium is balanced. Check the oxygen 2, and here also 2 oxygen, so completely balanced chemical equation is 2K solid form, 2H2O liquid form, 2KOH aqueous form, and hydrogen gaseous form H2. That's it. In this question, balancing the chemical equations, the first one is nitric acid HNO3, calcium hydroxide. When both reacted, you are getting calcium nitrate and water. So you need to balance this chemical equation, right? So how you will start? So you observe which is the maximum first, which element is more in number, that you have to choose, right? So here H2O, so this side hydrogens 2 you will observe, and if you observe OH, here 2 hydrogens and 1 hydrogen. So how to proceed here? I multiply 2 here, and here 2 hydrogens. So we are multiplying 2 with like this. So total 4 hydrogens left hand side and 4 hydrogens left hand and 4 hydrogen right hand side. Now you just check NO3. So nitrogen 2. So here NO3 this side 2. So this side also 2 matched. And OH oxygens if you take. So this side 6 oxygens plus 2 8, and 3 into 2 6 oxygens plus 2 8 oxygens, and calcium 1. So completely balanced chemical equation. Coming to the second one, NaOH plus H2SO4, Na2SO4 plus H2O. So this is the equation. How you will start? So maximum number of elements method if you start. So you observe SO4 already matched. Nitrogen sodium is 2 here and 1 sodium here. So I multiply with 2 here. So 2 NaOH, H2SO4, Na2SO4 plus 2 H2O. Why we are writing 2 H2O? This side if you write 2, so 2 hydrogens and 2 hydrogens. So total 4 hydrogens are coming. So to balance the hydrogen, I am putting 2 here. So if you are keeping like this, other elements are also getting balanced. That you can check here. And the last one, AgNO3 NaCl, AgCl plus NaNO3. So Ag 1 1, NO3 1 1. You can check like that. And sodium is 1 1 and chlorine is 1 1. So it is already balanced, right? And last one, BaCl2 plus H2SO4, BaSO4 plus HCl, barium 1 1, chlorine here H2, right? H2 and Cl2. Here HCl is there. Here you have to put 2 here, and SO4 matched. So then it is balanced. Just you keep 2 here, then it will be a balanced chemical equation. Similar way you can check, write balanced chemical equations for the following reactions. Potassium bromide, barium iodide. Potassium gives rise to potassium iodide and barium bromide. So potassium bromide means KBr, barium iodide BaI2. Potassium iodide is Ki, and barium bromide is BaBr2. So now just already you can check it is simple to balance. So 2 kBr, if you put this 2 factor, that is getting balanced, that you can check. You already know the procedure, right? Zinc carbonate gives rise to zinc oxide and carbon dioxide. So zinc carbonate is ZnCO3 and ZnO is the zinc oxide and carbon dioxide CO2. So here it is already balanced. CO3, oxygens 3, 2 plus 1 3, carbon 1 1 and zinc 1 1, already balanced chemical equation. Hydrogen chlorine gives rise to hydrogen chloride. H2Cl2 gives rise to 2HCl was the equation. Just you keep a 2 here, then it is getting balanced. Magnesium plus hydrochloric acid gives rise to magnesium chloride plus hydrogen. Magnesium in the solid form, hydrochloric acid in the aqueous form, magnesium chloride is in the aqueous form and hydrogen is in the gaseous form. So simply if you keep 2HCl, the equation is getting balanced. You can check like this. So what does one mean by exothermic and endothermic reactions? So exothermic reaction means heat will be released and endothermic reaction will be heat will be absorbed in the chemical reaction. You can give any example that you like. So here I have chosen these two examples. When CH4 methane is oxidized, reacting with oxygen, heat will be released in this procedure. And when plants are in the photosynthesis process, plants take sunlight energy and water that we are giving to the plant, and they take carbon dioxide and they generate glucose and oxygen will be released. So in this is the best example for the endothermic reaction. Here heat energy is taken. So this example you can give here. Why is respiration considered an exothermic reaction? So what happens in the process of respiration? So respiration involves breaking down glucose during oxidation to produce energy in the form of ATP along with carbon dioxide and water. Heat is released during this process, making it an exothermic reaction. So in the process of respiration, heat will be released. That's why we name it as an exothermic reaction. So why are decomposition reactions called opposite of combination reactions? Write the equations for these reactions. So what is a decomposition reaction? A single compound breaks down into 2 or more substances. That is known as a decomposition reaction. Example, when water electrolysis process, it is getting separated as hydrogen and oxygen gases. And coming to combination reaction, 2 or more substances, they combine each other to form a single compound. So H2 and O2, when they are combined, we are getting water. So decomposition reactions are called the opposite of combination reactions, that you can observe over here. So that is all for today's lecture. Thank you.